In the previous examples, a linear equation was provided to us, but we can also construct a linear equation given different pieces of information. For instance, in example 7, we want to find an equation still of the form y equals mx plus b, using that slope-intercept form, where our line has to pass through these two particular given points. In the case where we're given 2 points, we need to start off, in any case, I find it's easiest to start off by finding the slope of our line. In the case where we're given 2 points, we can find the slope using the equation for slope, which is to take the difference of the y coordinates over the difference of the x coordinates. We have that subscript notation, y2 minus y1, x2 minus x1. It doesn't matter at all which point you consider to be x1 and y1 or x2 and y2, as long as you're consistent. That means there's 2 different ways we can express this. We could express the numerator as 26 minus 22, the difference of those 2 y values, over negative 7 minus negative 6, the difference of those 2 x values. What's important is that since I used 26 as my first y value, I used its corresponding x value as the first value in the denominator. That means we could also write this as 22 minus 26 over negative 6 minus negative 7. In this case, I used 22 first in the numerator, and I used negative 6 first in the denominator. As long as you use those paired values first, everything should work out fine. We could evaluate either of these. We'll go with the first expression. We'll get 4 over, in this case, we'll get minus, minus becomes plus, so we'll get 4 over negative 1, or negative 4 as our slope. At this point, I like to just go ahead and rewrite the information that I know. I found that the slope is negative 4, and the information that I still need to find is my value for b, that y-intercept. To do that, we take some information that we already know for x and y and plug that into the expression. In this case, I'm going to take the pair negative 7, comma 26 and plug in those values. Because they're a solution, they have to be a solution to the equation that we're constructing. So we'll plug in 26 for y and negative 7 for x, which leaves us with a single variable left to solve for, which is that y-intercept of b that we're after. This will give us 26 is equal to 28 plus b. To solve for b, we can move 28 to the other side by subtracting it from both sides. As long as we perform the same operation to both sides of an equation, we haven't changed the value of that equation, just the way that it looks. This will leave us with 26 minus 28, or negative 2 is equal to b. That means we found our equation because we already found that our slope is negative 4, and now our y-intercept, that b value, is minus 2. And we have an equation in slope-intercept form. In example 8, we want to do the same thing, but we're given different information. In this case, we're told the slope of the line and a point that it passes through. This is the easier version of this type of problem, because if we're given that information, we can go ahead and plug that into that slope-intercept form. And we know that our equation is going to be y equals 2x plus b. We don't need the slope equation. We just have to take our x and y pair, substitute those into the equation, and solve for b. In this case, that will give us -1 is equal to 4 plus b. We can subtract 4 from both sides of the equation to isolate b by itself. And we get -4 is, we get -5 is equal to b. That tells us that our linear equation will be y equals the 2 that was given to us as the slope times x minus 5, the y-intercept that we found. Again, I find example 7 to be a lot easier than example 8. So let's take a look at one more problem where we're given the coordinate pairs, the two coordinate pairs, just to see another example of how this works. Since we're given two coordinate pairs, the first thing we need to do is find the slope. That's not provided for us. Our slope equation is the difference of our y coordinates divided by the difference of our x coordinates, where again we keep the consistency. If we're using 6 as our first y coordinate, then we need to use 10 as our first x coordinate. This will leave us with 4 over 5. And we know our value for m will be 4/5. And then we can substitute in either coordinate pair into that equation to solve for b. We'll let y equal 2. And in place of x, we'll substitute in 5. Which will give us 2 equals 4/5 times 5. Keeping in mind we can always write a whole number as a fraction over 1. Diagonal canceling, the 5s will cancel, leaving us with 4 plus b. And then subtracting 4 from both sides will leave us with -2. So our linear equation in this case is y equals the slope of 4/5 times x minus the b value we found, which is -2.